Here is another interesting problem. Find maximum sum of a subarray of size k. The problem statement is given an array of positive numbers and a positive number k. Find the maximum sum of any subarray of size k. So here is the array and the size of subarray is defined here, which is 3. So what are the possible subarrays we can create from this array? So the subarrays will be 2, 1, 5. One subarray is this. Second subarray is 1, 5, 1, and third is 5, 1, 3, and the last one is 1, 3, 2. You can see the size of all the subarray is 3, and if we do the sum, then the sum of this subarray is 8, the sum of this subarray is 7, the sum of this subarray is 9, and the sum of this subarray is 6. So the maximum sum we can obtain through this subarray, and the result is 9. So this is the problem statement, and now let's think how we can solve this problem. The simplest approach to solve this problem is the brute force approach, in which we find the sum of all the subarrays of size k, and after that we return the max sum. So in this approach I am using two for loop, the outer loop and the inner loop. So the outer loop, when outer loop points at this index, so suppose the value of I is 0, then the inner loop will run from this window to this window, I mean at this point to this point. So if you see, the value of I is 0 and the value of j is less than 3, so it will goes from this window 0 to 2, and it computes the sum. So the sum obtained here is 8, and here we compute the max sum. So max sum, initial value of max sum is 0 and this value of sum is 8, so the value of max sum is 8 here. Now in next iteration, when the value of I point at this index, then the inner loop will run from this point to this point. So the sum obtained here is 6, and if you see, there is no change in the max sum value. When the I point at this index 2, then the inner loop will run from this point to this point, and we compute the sum. The sum obtained here is 9, so the value of max sum is 9. Similarly, when the value of I point at this index, then the inner loop will run from this point to this point. So in this way we computed the sum of all the subarrays of size k, and after that we came out of this loop and we returned the max sum, which is 9. So you can see we run a loop from 0 to array length minus k. The reason being, we need the subarray of size k. So that's why we are running our outer loop will run from 0 to array length minus k. So the time complexity of this approach is n cross k, where n is the length of array and k is the length of subarray. So this is the time complexity of this approach. And let's in the next approach, let's discuss a better solution which can solve this, through which we can solve this problem in O and time complexity. The better way to solve this problem is by using a sliding window approach. So in a sliding window, the width is defined and the width is equal to the value of k. So you can see the first sliding window is from this point to this point. So we need a sum of subarray whose value is equal to k, and the value of k is 3. So we need to pick a subarray whose length or whose size is equal to 3. So the first window is from this point to this point, and here is the two pointer, which I'll explain in few minutes. So in a sliding window, what we do is we first compute the sum of this window. Then what we do is we slide a window by one step, and to slide a window by one step, what we need to do is we need to exclude the previous element from the window and include the new element in a window. So you can see here we move the window by one step. We excluded the previous element and included the new element. So suppose the sum of this window is 8. So we have already calculated the sum of the subarray. So by using this, we slide a window by one step. So what we do is we have excluded this element, so we subtracted 2 from the sum we obtained, and we added this the value of this new element. So the sum obtained here is 1. Similarly, in next step, we need to exclude this element, and we need to include this element, so that the width of this sliding window is always equal to k, which is 3. So the next sliding window contains this element 5, 1 and 3. So what we need to do is, so the previous computed sum is 7, we need to subtract 1 from it, so we get 6, and we need to add this 3 to it, which is 9. So similarly, in next step, we need to exclude 5 from this window, and we need to include 2 in this window. So by using this approach, we can easily find the maximum in O and time complexity. And if you see the code, here I have declared 3 variables: start, sum and max. And start is this one, starting position, and end is also initially point at this index. Then what we do is we keep start at this position, and we increment the value of end till it's not equal to k. It means we need a width of a sliding window equal to k. So you can see the start pointer is 0 and the end pointer is equal to 2, so which is equal to k. We have 3 elements in our window. Then after each step, we increment both start and end pointer by one step. So for this, I have already explained, we need to exclude this element, previous element, and we need to include the new element. So here the value of s is equal to 3 and end is 3. Similarly, when we slide one more step, then the value of s is 2 and the value of end pointer is 4. So this is what this code does, and at each step we compute the max sum, and after that, after when we came out of this loop, we return the max sum, which is 9. So you can see this approach is much better than our previous brute force approach, and the time complexity of this approach is ON. So this is how we can solve this problem, and that's it for this video. For more such programming video, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.